You learn how to prepare your data, train your model, make predictions, and deploy your model. Do you know that the logistic regression is one of the most popular machine learning algorithms? It's used in a variety of applications such as predicting customer churn, diagnosing disease, and detecting fraud. In this video, I'll teach you how to implement logistic regression in Python using the Scikit-learn library. Hi everyone, welcome to my YouTube channel. My name is Asiba and I'm a Python developer focusing on machine learning. In this video, I'm gonna show you how to implement logistic regression in Python using the Scikit-learn library. Logistic regression is a supervised machine learning algorithm that is used to predict binary outcomes. Binary means the outcomes has two values, two categories. So the outcome going to categorize or predicted as one of the two categories. It works by fitting a linear model to the data and then using a sigmoid function to convert the linear prediction into probabilities. So in this tutorial, I'm going to show you step-by-step process how to implement logistic regression to predict customer churn data. The first step is data preparation. Data preparation is the first step for machine learning engineers to make ready your data for machine learning model. In this step, you first need to load your data into Python, into Pandas data frame to understand the nature of the data. You can use the Pandas library to read the data from a CSV file if you have the data in CSV file. But in this tutorial, I want to show you how to generate a synthetic data set in Python using the Python Pandas library. Here is an example of how to auto-generate customer churn dataset. You can import the pandas as PD and NumPy as NP, and set the number of rows you want to generate the dataset. For example, in this, I just set 100 number of rows, and then create a dictionary to store the data. The dictionary contains different columns, keys and values. The first one is the customer ID. It just identify each customer. Gender, the customer gender has two values, two categories, male and female. So you can set the size, the number of rows. Senior citizen is 0 or 1. Partner, which is yes or no, is the customer partner. Dependence, phone service, multiple lines, internet service, and churn. Churn is our target variable, and the others are future variables for our machine learning. Okay, now create the data frame. The data frame, just use Pandas data frame to create the data frame, and you can save to CSV file to keep your file in the CSV format. Now the data set is saved to the data.csv file. Once you save that, you can load that data into Pandas data frame to understand, analyze your data, okay? Now the data is loaded and I can explore the data and see the nature of the data. For example, the first 5 rows. Yeah, you can see that there are a number of columns, and the last column is the target variable that's going to predict the customer is churn or not. So it has two possible outcomes, yes or no. And this data, some of the column and values are categorical, or it is a text value. So you need to convert or transform into numeric value because machine learning couldn't understand, couldn't predict the text values. There are many reasons that you need to transform into numeric values. To do this, you can use LabelEncoder. LabelEncoder is a pre-processing technique in machine learning used to convert categorical data, which is represented as text labels. For example, here the gender column has male and female as a text values, so you need to transform into numeric values. That's why we need to use LabelEncoder that's going to encode your text values into numeric. And other partner dependent phone services, multiplier storage service, even though the churn, which is the target variable, should be transformed into numeric values, either 0 and 1. So this LabelEncoder assigns a unique integer to each category in the categorical variable. For example, in the gender, let's say male is, and it has two values, either male and female, and it's gonna be transformed or converted into numeric, which assigns zeros and ones to each category. This transformation is necessary because many machine learning algorithms, including logistic regression, decision trees, support vector machines, work with numerical data and require numeric input futures. That's why we need to transform into numeric values, okay? There are many reasons why we need to transform the categorical variables into numeric values. The first one is numerical representation. Machine learning algorithms, particularly those that rely on mathematical computations and require numerical input data. Yeah, because text labels or categories cannot be directly used in these algorithms, and LabelEncoder can help us to convert those labels into numerical values. And the other is consistency. So the futures must have consistent input values. So that's why we need to transform into numeric values. So it ensures that each category is consistently represented by the same integer value. For example, if male is encoded as 0, will always be encoded as 0 throughout the data set. So it is consistent, making it easier for the algorithm to learn patterns, to find and discover new insights. And the other reason is that transforming or converted the categorical variables into numeric is reduce memory usage, because string values takes more memory usage. That is why we need to transform into numeric. Yeah, using numerical values can reduce memory usage compared to storing text labels, especially when dealing with large data sets. The other is easier comparison, because it is easier to compare numeric values than string values or text values. Numerical values allow for easier comparison and mathematical operations. For instance, you can easily compare whether a future is greater than or less than a certain value. And compatibility issue. So if you transform into numeric, it could be simply compatible. Many machine learning libraries and models are designed to work with numerical data only. That's why we need to encode those futures into numeric values. Okay, for example, this you need to encode the categorical futures. You can use the LabelEncoder class from the Scikit-learn library to perform this task. And so in this case, I have just identified the list of categorical variables from the data set. For example, gender, citizen, senior citizen by default numeric, so I don't need to just convert. For tenure is also numeric. I don't need to just convert to numeric. So I just identify categorical or text variables only, including target. So here I have a list of columns having categorical values, and I can iterate over all in the columns. And I just define the class, which is LabelEncoder. Okay. Then you can call the data frame and call that column, and each column in the data set, in the data frame. And I can transform into it and transfer function from LabelEncoder and pass the each column values into this function. Then you can store this to encoders as code that is LabelEncoder. Okay, now let's check. Let's run this code and let's see that all the values of categorical columns are transformed or not. Okay, let's run the data frame again. Yeah, of course. For example, gender is converted into ones and zero. One represents the male and zero represented female. And customer churn, yes or no? Is the customer churn, yes or no? One, yes, zero is no. This is our target variable that's going to. So if your given variables are, future variables are this, and it's going to, once you train the model, it's going to predict the input data, either the customer is churn or not. So the fit transform method in this is a convenient way to both fit that's going to learn the mapping, and transform is also apply that mapping to your data in a single step when using LabelEncoder. It's commonly used when encoding categorical variables. So this is one of the best things that you can do to transform or convert or encode categorical variables into numeric. That's it. Okay. Now, once you encode all the categorical variables into consistent values, you can extract the futures from the pandas data frame. And in this case, customer ID is not important for our model, and churn is also our target variable. So you have to drop the columns from your data sets, from data frame, and you can save to X as a variable. All futures can be saved as X variable, and the Y represented the target variable that's going to predict, okay? That is called a churn. It has two outcomes, either yes or no, either 0 or 1. Okay, next, you need to split the data into training and test sets. So once you train the model, you can test the performance of the model using testing set. So that's why we need to split the data set or the data into training and test set. You'll use the training test split function from the Scikit-learn. So you can do that X train, X test, Y train, Y test, and train test splits, and pass the futures as X and the target variable as Y. And you can split the data set into trained and test set. The test size is 20%, and the remaining 80% is the training data. Okay, that's good. Okay, I should run this now. That's good. Okay. In some cases, your data values may vary. So we need to standardize or normalize the data values. Okay. So we need to use StandardScaler method. The StandardScaler is a processing technique in machine learning that used to standardize or normalize the futures of a dataset. It scales the futures so that they have a mean of 0 and a standard deviation of 1. This transformation is applied independently to each features, making the mean of each feature 0 and the variance is 1. Standardization is also sometimes referred to as z-score normalization. So here, how standardization or StandardScaler works and why it is used for. The first one is mean centering. It just subtract the mean or the average values of the future from each data point. This step ensures that the transformed data has a mean of 0. And scaling. Scaling just divides each data point by the standard deviation. By the standard deviation of the future. This step ensures that the data point has a standard deviation of 1. So this is the formula that's going to standardize our data points. So x standard equals x minus, that is the mean divided by the variance or standard deviation. So x standard represents the standard value of each data point, and x is a data point from the future, and this represents the mean of the future, and this one is the standard deviation of the future. So it's going to just standardize your data points. That is good to train your model. Finally, you need to scale the numerical features. You can use the StandardScaler class from the Scikit-learn library. Okay, now I can just create a class StandardScaler from Scikit-learn pre-processing module, and I can create X string because I'm gonna standardize the training and testing set of the data. X string is scalar dot fit transform that's going to fit, learn the mapping and apply the mapping at the same time, and pass X string. And the other is X test. Okay, that's good. Now I can run this code and I can now check the values of X train. For example, the first 5 values, let me check. The standardization is this one. It is not that much greater than 1 and less than 0. Okay, so it is standardized. That's good to standardize your data. Okay, I have now finished the data preparation steps, and the next step is training the model. Now you can train the logistic regression model. I'll use a logistic regression class from the Scikit-learn, and I can fit the training and the training data to that model. Okay. And the third step is once you train the model using training data sets, you can evaluate the performance of the model using test sets. Once the model is trained, you can evaluate its performance on the test set. You can use the predict function to make predictions on the test data and then compare the prediction to the actual targets. Okay, you can use predict function and pass the test data X test to the model. Then you can use a variety of metrics to evaluate the performance, such as accuracy, precision, recall, and F1 score. You can use the metrics module from the Scikit-learn library to calculate these matrices. Okay. You can also use classification reports from these matrices, and you can evaluate the performance of your model. That's good. So you can see that the precision of the 0 class is 56, and the recall is 45, and F1 score is 50. And the one is 45, 56, and the accuracy is 50%. It is not bad. So now the accuracy of the model logistic regression in this training data set is 50%. Okay, now you have finished the training and evaluating the performance of the model. You can optimize the performance of the model using different training parameters. I will go through the performance optimization parameters in the next video tutorial. Stay tuned and don't forget to like, share, and subscribe. Okay, the next step is model deployment. Once you are satisfied with the model performance, you can deploy it to production so it can be used to make predictions on new data. You can save the model to a file using the pickle library. If you are new to pickle library, you can watch the previous tutorial. You can find the link under description box of this video. Okay. Now let's save the model to pickle, and you can load the model back into the Python and use it to prediction on new data set. To test your model, you can use synthetic data. You can create a set of testing data. Here is an example of how to generate testing data. Simply, you can use the previous method, how to create a testing set data, and it has no customer churn. So it's based on the model, the training model. Based on that, you can see that this model going to predict the customer is churn or not. Okay. Now you can encode into numeric values. You can use the same label encoder as in the training data. And finally, you can predict the testing data, and you can see the result of the classification. In this case, all the customers are churn. You can read, yeah, this, yes. So I hope you enjoyed this video. Don't forget to like, share, and subscribe. So in this video, you learned how to implement logistic regression in Python using the Scikit-learn library, and I covered data preparation, data modeling, model evaluation, and deployment. I hope this tutorial was helpful. If you have any questions, please leave a comment below. Thanks for watching.